Ever wondered why your train might screech to a halt in autumn? It's not just the weather, it's a physics problem involving leaves. When trees shed their leaves, they form a slick layer on tracks, reducing friction and causing delays. But here's the twist. Scientists are using AI to predict when those leaves will fall, turning a seasonal nuisance into a manageable challenge. Let's break down how machine learning is helping us stay one step ahead of nature's slowdowns. The core issue isn't just leaves on tracks, it's timing. Traditional methods rely on manual inspections or limited data, like weather stations or historical records. But this research is leveraging satellite tech and machine learning to create precise, real-time forecasts. Think of satellites as supercharged magnifying glasses. They capture high-resolution images of entire landscapes, letting us monitor individual trees and their leaf cycles with unprecedented detail. With constellations like Sentinel-2 providing data every few days, we're getting a dynamic, almost real-time view of plant health. But how do we turn this data into predictions? Enter machine learning. Earlier studies used basic models, like regression, to link weather data and satellite imagery to leaf fall. They found that spring events correlate strongly with temperature, while autumn relies on metrics like NDVI, Normalized Difference Vegetation Index. NDVI measures plant health by comparing near-infrared and red light reflection. It's like a plant's vital signs, showing how much chlorophyll it's producing. But even these models struggled with autumn's complexity, with errors up to 10 days. That's where this study shines. The researchers are using LSTM networks, long short-term memory, a type of recurrent neural network. Imagine a model that remembers patterns over time, like how you recall a song's melody. Leaf fall isn't a single event. It's a gradual process influenced by temperature, soil moisture, and tree species. LSTMs excel at spotting these long-term trends. By feeding them satellite data, like Sentinel-2's 10-meter resolution images, and weather models, the team trains the AI to recognize the precise signals of leaf drop. They also clean and normalize data to eliminate noise, ensuring the model isn't confused by outliers. Why does this matter? Let's compare it to previous approaches. One study used NDVI to flag high-risk tracks, but it couldn't predict when leaves would fall. Another relied on rail-specific data, like tree height or wind patterns, but that's hard to scale. This new model uses global, publicly available data, so any railroad operator anywhere could use it. The goal? Turn vague warnings into precise forecasts. Picture this: a train company gets a heads-up weeks in advance that a stretch of track will be slippery, allowing them to adjust schedules or deploy cleaning crews. This isn't just about leaves and trains. It's about how technology can solve real-world problems with precision. By combining satellite eyes in the sky and smart AI, researchers are turning complex natural patterns into actionable insights. Next time you're on a train, remember, behind the scenes, science is working hard to keep you moving, leaf by leaf, data point by data point. Thanks for watching. If you like this deep dive into AI and ecology, hit subscribe for more stories where tech meets the natural world. And let me know in the comments, what other real-world problems do you think AI could solve? So here's the science. When leaves fall, they create a hydroplaning effect on tracks, reducing friction. But predicting exactly when and where this happens, that's like trying to guess the perfect moment to jump into a pool. Too early and you're drenched. Too late and you're stuck waiting. Enter NDVI, the satellite-powered greenness meter for plants. By tracking how NDVI changes, researchers spot when trees are about to shed their leaves, like a plant's early warning system. But here's the magic. It's not just about observing leaves falling. It's about forecasting the exact timing. That's where AI steps in. The study uses LSTMs, models that remember patterns over time. Imagine teaching a computer to recognize the seasonal rhythm of a tree, how its NDVI dips as autumn approaches, like a clock ticking toward leaf fall. By feeding it years of data, the model learns to predict when that dip will happen, down to the day. Now, how do you teach a machine to do this? It's like tuning a radio to the perfect station. Researchers tweaked thousands of settings, like how many layers the model should have, how fast it learns, and how much to forget as it processes data. These are called hyperparameters, and getting them right is key. Too simple and the model misses the forest for the trees, too complex, and it gets lost in the noise. Through trial and error, they found the sweet spot for accuracy. The proof: the model nailed predictions in places like Harvard Forest, correctly forecasting when trees like birch and red maple would drop their leaves. But this isn't just about forests. It works in cities too, where street trees and parks create their own leaf fall risks. The tech is adaptable, turning raw data into actionable insights. Why does this matter? Picture rail companies using this AI to deploy leaf-busting trains or adjust schedules before tracks get slick. It's not just about avoiding delays. It's about making transportation safer and more reliable. And who knows? Your next train ride might be smoother because a machine learned to read the trees. Thanks for sticking with us. If you want to explore how AI is reshaping everything from weather forecasts to wildlife conservation, hit subscribe. Let us know what you'd like to dive into next, because the future of tech is always evolving. Stay curious, and we'll see you in the next episode.